This is Project SmartButton, an affordable internet-connected button with no limits designed to compete against options like the Flick button, Logitech Pop, or Philips Hue light switch. Not only does it compete, it fixes some of these devices' biggest flaws while using a well-known and satisfying to press enclosure, the Staples Easy Button. Despite having less buttons, it does more than either of the other options, and you can build it at a much cheaper price. In this video, I'm going to show you where to buy the parts, and I'm going to build my second to show you how to build your own. Let's get smart. This project is completely open source, and the materials list to build it can be found on my GitHub, which will be linked in the video description. To compare, we're trying to beat the price of a Flick 2 starter kit, which is $80.60 Canadian per button and includes the all-important Smart Hub. More on that at the end of the video. All of the prices in this video are in Canadian dollars, which as of writing this script trades for 79 US cents. Dang it, why does everything cost so much here? Anyway, the parts we need are a Staples Easy Button. These can be found for $6 on their website and can also be found used at a thrift shop for practically pennies. Something to cut into the button with. I'm using an off-brand Dremel, but you can use pretty much anything that can cut into plastic. We need to cut a hole for the USB port and LED, and also make some space inside of the Easy Button to fit the electronics. Soldering gear. Obviously, you're going to need an iron and some solder. I recommend getting a sponge for cleaning and maybe a solder sucker if you make a mistake and need to desolder components. I'm not listing a price for the last two items, as they're just tools that you can use in the future for other projects, and besides, you might already have these tools. A PCB. This piece is a key component of the project, as it's the centerpiece that all of the components attach to. Credit to my buddy Kelvin for designing these and buying them for me so I can escape the shipping price. The actual boards are only $250, and that's for 5 of them. Depending on where you live, shipping prices will vary, but if I were to buy them again, it would be about $12.50. Since this price is for 5 boards, let's divide by 5 to get price per board, which is about $3. We're looking good so far. A microcontroller. This is probably the most important part of the build, and also the most expensive. The microcontroller will contain the Wi-Fi transmitter and is the device that we are programming. The code is on my GitHub, and it works with either ESP8266 or ESP32 microcontrollers. And the PCB fits into the 16-pin variant of these boards. The ESP8266 can be found on Amazon for $23, and that's for 3 of them. The next thing we need are the parts. Kelvin used digikey.com to get an SMD buzzer, that's this tiny square thing, a 1 kilo-ohm resistor, an LED, and a button. These things can be desoldered from other electronics or found in cheap electronics kits, and they're pretty valueless, so I'll just add $1 to the unit price. So, our total price for one button is $17.66. Keep in mind that when you buy the parts using these exact locations, you'll have enough parts for 3 buttons. And if you get a couple extra microcontrollers and components, then you'll be able to use all your PCBs and have enough for 5 buttons. These things are super useful as light switches, so if you have a large enough smart lighting network in your home, then you may want to consider using these as switches. Building the smart button is going to require you to get your hands dirty. First, you need to take apart your Staples Easy Button. Okay, so in front of me here we have the Staples Easy Button, and also in front of me here we have the iFixit Tech Toolkit. What we're gonna do, we're gonna take this apart. That's what we're gonna do. There are 4 screws at the bottom, which will allow you to take off the gray housing and red button. This'll work. I'm gonna stab myself, aren't I? Oh, there goes that one.
That was easy.
Thanks for that. And there we go.
That was easy.
Underneath is a piece of metal that should just pull off, and at that point there will be more screws to take out the electronics. So let's get rid of this thing, because we don't want this. I mean, it's cool and all, but we don't need it. We want the thing inside. Or, I mean, we don't, well, you know what we want. Okay, that just lifts out of the way. This is our metal piece again. We're gonna want to keep that. These have screws. Okay, for some reason I didn't think there was gonna be screws here, but of course there are screws. I literally forgot, I literally just left out all the screws for my final build except the ones on the bottom. You guys can do the same if you want. I mean, free screws can sometimes be useful, you know? You know what? We don't need this. Peace out. That was actually surprisingly easy. Ha! Get it? Because it's an easy button? Oh yeah, you might want to get the batteries as well. There's a second layer underneath where the circuit board was that contains the speaker and battery compartment. Oh, these aren't glued in on this one. That's interesting. If you have a use for a crappy little speaker, go ahead and keep it. But I know what I'm doing with mine. And now we're gonna cause some unfathomable destruction. It works. Okay, now that we have the easy button disassembled, let's get out the Dremel. Actually, sorry narrator, it's not just Dremel time just yet. First, we actually need to label where we're gonna do our Dremeling, because you know what they say, cut twice and measure once, right? All right, here we go. So, check these weights out as well. The first place that's probably the most important place we need to Dremel out is the front of the whole thing. We need to take out a pretty significant chunk around this area because that's where our USB port's gonna go. Oh, there we go. Make sure you have a pretty big opening just because in case your thing isn't aligned perfectly. I'm also going to mark a spot on the bottom of this that lines up just because that way, since the USB port is on the very bottom of this, that way I just have more room to work. Next thing you're going to want to do is absolutely destroy the battery cover because it is absolutely not necessary. So what I did in my first one was kind of took out a pretty big chunk. You're going to want to get rid of this piece too, obviously. Here's my PCB and my controller stacked on top of each other, and I can just take a look, and I just dropped my Sharpie on the ground. That looks like it will work. So let's keep going. And of course all of this is just rough, and we'll see more of it once we actually start taking this thing apart. This little stubby's definitely got to go, but I don't really need to color that in because I know it's got to go. Now the next, and this is another important piece, is that you need to cut out on the sides of this thing. So gotta be careful here because you don't want to mess up your ability to put it back together. But I'm gonna flip over my controller, and you can see here, I gotta make sure that my pins on my controller are accessible, right? So I'm gonna take two little slices on the left here and on the right here. These can be rough because it doesn't really matter, it's just that way you have more room to work with. I think that might be all the actual cutting we need to do. Oh, you also want a bunch of space on the front here because that's where your LED is gonna go, right? So if I take a look and I grab my existing one, you can see here, that's exactly what I've done, right? I've put a massive hole in the front of it, and then I've got the battery cover pretty much destroyed, and there's a big hole in it because it needs the space for the microcontroller. Now we can go to our undisclosed location and start destroying this thing. Hello and welcome to an undisclosed location where we have a crappy table, even worse audio, my easy button, and the spin machine. There we go, that looks like liquid. Okay, welcome to the same place. I just moved things around. So here's my board, and you can see it's in two pieces, and I'm going to take the bottom piece off right now. This is my ESP8266, my microcontroller, and I am not going to do anything with this right now because I don't want to. So this is the thing. As you can see, we've got a spot for our button, an LED, and our SMD mount speaker. So I'm gonna start with the button since I think it'll be the easiest. Oh, it's attached. I'll call that a win. Please melt my solder. Okay, that dropped a big bubble down there. Did that work? Let's see. Okay, and I'm back from my short 2-second break where I text my friend and ask him which way the thing goes. So, I already forgot which way the thing goes. Okay, so this is the part of the video where I update you on what's been going on. I've had a working SmartButton for about a year, but I really procrastinated in making a second one because I didn't have a safe soldering environment. Because of that, this video has been really held up, and even though I attempted to make a second SmartButton, there are some issues with my soldering job that I haven't had the time to figure out. I'm going into university in literally less than a month, and I've been working on prep courses this month, so I don't really have the time to completely finish the video. But I still wanted to share it with you since I've put so much work into it already. If you really want to build your own SmartButton, feel free to contact either myself or Volvo on my Discord, linked in the description. The software bit is extremely simple, and Volvo can guide you through the hardware bits and ordering the PCB. Thanks for watching the video. I know it had a sudden and kinda crappy end, but I still hope that you enjoyed it. Normally I don't release my videos unfinished like this, so if you want to see more, make sure to subscribe. Remember to keep building and keep climbing.